Hello, and welcome to Art and Code Homemade. My name is Golan Levin, professor of electronic art at Carnegie Mellon University and director of the Frank-Ratchye STUDIO for Creative Inquiry, our laboratory for atypical, anti-disciplinary, and interinstitutional research and programs at the intersection of the arts, science, technology, and culture. I am thrilled to welcome you today to the 5th edition of our sporadic Art and Code Festival, which is concerned with democratizing the cultural and creative potentials of emerging technologies. Our festival runs now through Saturday evening, and you can find more information about our festival, including a complete schedule of presentations at artandcode.com/homemade. We have also a Discord server to support community conversations. And if you are interested in participating in those chats, we ask you to please register at artandcode.com to receive the link. These are dark and isolating times. It's January in the Northern Hemisphere, and the days are short and cold. Civic life has fractured. Authoritarianism is on the rise, and it feels like the twilight of American and representative democracy. We've spent more than 300 days indoors with no clear end in sight, and quarantined due to COVID-19, we long to see our family, friends, collaborators, and peers. The joke goes that we are not working from home, but rather living at work. Yet as artists and designers, many of us have been separated from the tools of our trade. Our studios, makerspaces, and laboratories are closed so that we are limited to what we can make in our homes. And more than ever, we also feel alienated by the mass-produced nature of our material culture. How can we stay vitally creative and connected at this moment? Excuse me. In this context, we are thrilled to present Art and Code Homemade, a free online festival featuring inspirational talks by creators we admire who work with digital tools and crafty approaches to make things that preserve the magic of something homemade. Our festival features a wide range of practitioners who are exploring poignant and personal new approaches to combining everyday materials, craft languages, and cutting-edge computational techniques, gift cultures, cardboard and clay, and pocket supercomputing towards the neo-homemade. Our festival offers an extended conversation between creators working with digital tools, crafty materials, and tight constraints to make things that don't scale. Homemade is resourceful, personal, and community-driven. It's accessible and grassroots. Homemade means made with care. Art and Code Homemade, our festival, has been made possible by an award from the Media Arts Program of the National Endowment for the Arts, by the Sylvia and David Steiner Speaker Series at Carnegie Mellon University, and by support from generous donations to the Directors Fund at the Frank-Ratchye STUDIO for Creative Inquiry. Finally, the Art and Code Conference Series is a project of Carnegie Mellon University. Located in the city of Pittsburgh, Pennsylvania, we acknowledge that we operate on land that has been continuously inhabited for over 16,000 years, the traditional land of the Monongahela and Haudenosaunee peoples, past and present, and we honor with gratitude the land itself and the people who have stewarded it throughout the generations. This calls us to commit to continuing to learn how to be better stewards of the land we inhabit as well. Our first speaker tonight is Claire Hensger, a Brooklyn-based artist and designer exploring media arts and crafts. Claire is in many ways the origination point for the Art and Code Homemade Festival, which arose out of her graduate work here at Carnegie Mellon. And in collaboration with Leah Albaugh and Madeline Gannon, Claire is also a member of the 3-person curatorial advising team for Art and Code Homemade. Please welcome Claire Hensger.
Hi, everybody. Thank you so much for having me, and I'm going to share my screen now. So, as Golan mentioned, I've been increasingly interested in this idea of media arts and crafts and thinking about, honestly, like what that means. And so I actually selfishly have a question for everybody. And if you're in the Discord server, feel free to answer this here or like send me an email or something to think about. And it's like a question and also a hypothesis. I'll tell you the hypothesis after. But the question is, did you have a book when you were younger that was somehow like a DIY or arts and crafts or some sort of instructional sort of making guide for kids that had a lasting impact on you? And I asked this because it was a point of my research a couple years ago, and it started to get really interesting when everyone who I admired in the field of media and tech and art started to like immediately have an answer, which was like, yes, of course, it was the How to Make Paper Airplanes book, or like, obviously it was the origami book, or One of my favorite ones was the how to make a flipper. I hadn't heard of that, but it was like an excellent introduction that I believe came through Everest Pipkin. So tell me if you have one of these, because I've been collecting them for a while, because I think the tone of these books is what's really drawn me to the term arts and crafts and homemade as a really positive, love-filled, process-based, highly respectable genre of making. And I'm always interested in hearing more about like what other people's connections are to this idea. Golan actually introduced me to this book, which was called Good Times. And I think it's so lovely because here is a page from the book and it's 4 ideas how to spruce up your bicycle. And the whole thing is hand done and hand illustrated. And it's all about essentially like why you have no excuse ever to be bored, why you can constantly throw yourself into the process of making something with your hands at home during a rainy day with your friends. And the emphasis is on sort of relaying this information to you, not judgmentally and under the guise of fun, not as some sort of skill for a future job. This is sort of the craft angle that I'm interested in. So then the next word in like media arts and crafts is art. And there's a totally similar sort of style of book too that I find equally interesting, which are, I mean, it originated maybe in the Dada movement, but then was seen again in Fluxus with Yoko Ono, who created this grapefruit book. And it was a set of instructional drawings and performance pieces that were in the form of verbal instructions. So this one is a favorite of mine. It's called Snow Piece. Take a tape of the sound of the snow falling. This should be done in the evening. Do not listen to the tape. Cut it and use it as strings to tie gifts with. Make a gift wrapper. If you wish, use the same process with a phono sheet. And I think the same sort of attitude towards making and sharing the sort of instructions behind how to make something is also visible in the history of tech. And one of my favorite examples of this is Ted Nelson's Computer Lib Dream Machines, which is like a totally insane book that reads 2 different ways. Like you can read it from one side this way and then turn around and read it from this side the other way. And half of it is him sort of breaking down to a novice user why a computer could be a tool that they could interact with. And then the other side is this like sort of wild speculative future of his where he talks about what he thinks the future of computing as a sort of, I want to say, the craft-based medium looks like. And one of my favorite example is he calls attention to the I just realized I never said this out loud until right now, the telonograph, but essentially it was like one of the first writing tablets that used special sort of pen to transmit handwriting over signals. And he calls out this as like an interesting piece of technology and why has no one used this in computing before, which of course now if you look at anything from like the fax machine to the iPad is of course completely used. So I just thought it was an interesting way that his sort of speculation and his looking at tools and making started to dictate what actually happened in the future. Okay, so then if you fast forward, I think there's like this unbelievably interesting thing happening all over sort of HCI and computation and art. And it's sort of, I was exposed to it through the Studio for Creative Inquiry, which was Golan's lab, but this idea of sort of crafty approaches to technical problems. And I don't know, I think because I had been thinking so much about these sorts of arts and crafts books, I always think about, every time I come across a example of these that I love, I think about it as like what it would be as a rainy day activity for the future. So like, of course, this comes out of the Human Interfaces group at CMU, and it's using sort of 2 reflective spheres attached to Google Cardboard and computer vision to track your skeleton from inside of those spheres. So it's like a totally low cost way to do full body tracking for VR. But every time I see this, I just think of like this sort of do-it-yourself hand-drawn book page that could say like, track your own skeleton using 2 sides of a reflective sphere. And I think that sort of spirit is something that I've noticed I enjoy in every sort of project like this I come across. Doodle Lens, which is an app by Aidan Wolf, is something that I've been super excited by too, because it uses hand drawings and augmented reality to bring alive your creations. And so again, yes, of course, it's that technical term, or it's animate your own drawings in augmented reality, right? Like see someone skateboard. This is so great. This is someone who created
Hey, are you ready?
a experience for their daughter where they could ride their toy cat by putting a 360 camera on a stuffed animal, and like has a similar spirit. There's great examples of data visualization in materials like scarves. This person, I think, used a different color string depending on the temperature, and then at the end of the year had this data visualization map of what it was like that year in the weather. This is one of my all-time favorite projects. Make a racing game out of a sewing machine. Okay, so these people essentially created these tracks for their sewing machine, and they have a camera that has an AI that's essentially charting whether or not you go out of the like lane. So it's like a car racing sewing machine game. And I think this is such an excellent example of the kind of craftiness that I'm really excited about. And so, okay, now I'm totally like having my cake and eating it too, because as Golan said, I was involved in the curatorial side of this conference, but I also wanted to share some projects that I've been working on with a similar sort of mindset of like, for example, how to turn yourself into a paper doll, and using not only arts and crafts, but also using this element of technology now. And I wanted to say a big thank you to Roxy, who I think was 8 at the time when we did this, and she helped me demonstrate some of these concepts. So step 1 would be to draw some dresses, some jewelry, some hats, some shoes. And then you take a picture of yourself and you print it out and you cut it out. Then you use the puppet warp in something like Photoshop to realign all of the clothing to the original form. And then you put little paper tabs and cut out each of the clothes. And then you can start to build your own paper dolls of yourself with your drawings and have a little fashion show like we had here. And you can see she can switch out the earrings and the hats. You can make a drawing instrument, for example. You can turn your scribble into a musical instrument, and we used a capacitive touch interface. So I feel like Ted Nelson would be happy about that. Okay, so the first step was to draw a scribble and then to color in each intersection of the scribble in a different color, and that was Roxy's idea. And then think of a sound that should play when you interact with each section of the scribble, and then write that sound on the scribble. And then we were using the Stencil morph, but I think this would work with any sort of like touch capacitor that you have underneath the drawing. But you basically put the touch capacitor under the drawing, and then you record your sounds, and then you make an interface for playback. We use processing here. And then when you put it all together, you get this excellent kind of musical instrument. I love that so much. And then the last example I wanted to talk about was something I worked on 2 summers ago, and it was a 1-day workshop for kids. And the kids in the workshop were ages 8 to 11, I believe. And we made branching narrative phone app games in a day. So this is how to do that. Okay, the first step was actually to play Zork. I don't know how many of you, I wish I was on Discord right now, because I'm like, write in the chat if you've ever played Zork, but it's essentially a text-based narrative game that gives you a prompt, and then you can use text as so like turn left or go under. And it was one of the earliest computer games, but I think because kids today are so used to insane 3D graphics, like the idea of a magical page that talks back to you when you talk to it was like somehow a million times more exciting than a 3D game. And so we played some Zork, they got their minds blown. And then we looked at branching narrative structures and essentially how different nodes and different stories can lead back to the same point. And you can start to organize a story and organize an adventure and give a player different routes. And then the next step was they made their own flowcharts for the stories or the games that they wanted to play. So for example, this one, you start in the kitchen and you can either go to the fridge and pick poison, but then if you pick poison, it looks like you die naturally. And so they made these awesome flowcharts. And then once each node was established, they drew separate interfaces for each of those nodes, a visual representation of each element of the story that you could select on. And then we used a rapid prototyping app called Marvel, but I think there's lots of different like free prototyping apps now for like wireframing. And essentially what you can do is you can photograph each element of the story. You can create hyperlinks on the images and you can link it all together. And like all the kids did this themselves. And then you can start to make these iPhone games. So I want to show you some of my favorite ones. And then I'll also put in the Discord the links to these. You can play them yourself. There's some really excellent ones. This was the one that we saw the original flow chart for. So you click on the tree, okay? You can go up or down. Let's go up. Okay, we go back down. Those are your feet. Oh, I feel like I spoiled this game now. So if you click on the fridge and you click the poison, oh good, I clicked the Oreo. So I also died. And then the other game that I want to show you that made me so happy was skydiving. Okay, so the pilot tells you to jump. Do you wait to jump or do you jump now? Let's see, let's wait to jump. You finally jumped after multiple minutes. Let's wait to pull the ripcord. We fell to the ground unconscious. A cow lifts us and takes us to an evil cult where they want to burn us at the stake. We meet a woman. What do? We run away to the trees and we lived happily ever after. So there's lots of different ways these stories could go. And if you play them, you can find out for yourself. And enough about me and my work. I just wanted to give a little bit of insight to the curatorial process. And Leah, I hope this is okay. We were originally sort of taking notes and outlining why the word homemade and craft and materials meant a lot to us and how to sort of frame it. And Leah gave an unbelievably interesting interpretation of David Pye's The Nature of Art and Workmanship. And so this is my interpretation of her interpretation. But she was talking about how what distinguishes workmanship or craft or making in this sense from industry is the element of uncertainty, that there's a risk in the process that resolves itself via the maker's discernment. So their personal taste, their subjective goals, their knowledge, their past outcomes, as well as their dexterity, so their skills, but also the tools and the techniques that they have sort of already learned. And he is specifically rebutting the William Morris school of thought that says handcraft is about the dignity of the hand or some sort of aesthetic rejection of machines, but instead it's about the process of using your personal discernment and dexterity in conversation with a material as the outcome becomes more and more certain. And I'm so grateful to kick off Art and Code, and I'm so excited about all the speakers we have because I think everyone's personal taste and skill set is so unique and lets them make things that are both uncertain and beautiful and in a sense homemade. So thank you so much for having me, and I'm looking forward to the rest of the conference. Bye.
I'm no longer muted. Thank you, Claire. There we go. Thank you. You were the one speaker that we don't have questions prepared for because you are the person who is helping me come up with questions. But how has being alone in your isolation of quarantine of COVID changed your thinking about homemade and craft and creating things? And were you already there, or has
no, you know what?
has
Actually,
2020 changed your
I
thinking?
appreciate the question because I think I think I've always thought about homemade as this sort of act of love, this generous sort of thing you can do for someone else, this unnecessary but great gratitude from the other person's style of thing you can do. And I hadn't considered how much like homemade is also sometimes done out of necessity. So like whether you're in a community that isn't able to get something you need, so you need to make it yourself, or if you're locked in your studio apartment in Brooklyn and need to make things because otherwise you're going to lose your mind, that like there's sort of an urgency and a necessity to making things at home too, which I now can say that I've experienced.
I think a large part of what we're going to see at the Art and Code conference is people who are making things for different kinds different kinds of economies or non-economies. And by that, I mean people who are making things for themselves, for their family, for their friends, for their communities, for their ancestors, connecting with craft languages that might be thousands of years old, or which are being made as gifts for others as true gifts, which, could only come from me that could only go to you, and which are not offered in exchange for anything, but which are true gifts. And but also, especially when people make things purely for themselves, not even really confecting it, but just like making a tool for oneself. These kinds of zero scale prototypes that are one-offs. I think it's really, all of that is within play, I think, in this festival.
Plus the festival itself is homemade. I think that was another element of it. Like, we all put this together from our homes.
We're going to be seeing a lot of people's homes, and of course, we've been living in this rectangle for some time.
I know, this is my rectangle.
And in many of the presentations, we're going to see people's rooms at their studios, and get a kind of a feeling for how they're working now. Well, we will break here. Thank you so much, Claire. Next up will be Irene Alvarado at 6 o'clock. And so we'll see you soon. Thanks, everyone. Hello, everyone, and welcome back to Art and Code Homemade, Digital Tools and Crafty Approaches. I'm thrilled to welcome you now to the session with Irene Alvarado, who is a designer and developer at Google Creative Lab, where she explores how emerging technologies will shape new creative tools. She's also a lecturer at NYU's Interactive Telecommunications program. Irene Alvarado.
Hi, everyone. Very excited to be here. I'm going to talk today about a behind-the-scenes story of a particular tool called Teachable Machine. So as Golan said, I work at a really small team inside of Google. I mean, we're less than 100 people, which is small for Google size. Some of us in the lab, the work that we do includes creating what we call experiments to showcase and make more accessible some of the machine learning research that's going on at Google. And a lot of this work shows up in a site called Experiments with Google. And time away, we're sort of blown by what happens when you lower the barrier for experimentation and access to information and tools. And so today I want to tell you about one particular project and especially the approach that we took to creating it. So why am I speaking at a homemade event when I work at a huge corporation? I think you'll see that my team tends to operate in a way that's pretty scrappy, experimental, collaborative. And this particular project happens to be a tool that other people have used to create a lot of homemade projects. So to begin with, let me just talk about what it is. It's a no-code tool to create machine learning models. So that's a mouthful. So I think I'm just going to give you a demo. So I believe you can see my screen. This is sort of the homepage for the tool. It's called Teachable Machine. And I can create different types of what we call models in machine learning, basically a type of program that the computer has learned to do something. And there's different types. I can choose to create an image one, an audio one, a pose one. I'm just going to go for image. It's the easiest one. And I'm just going to give you a demo so you see how it works. I have this section here where I can create some categories. So I'm going to create 3 categories. I'm going to call this like neutral, or I could call this just like face or something like that. And I'm going to give the computer some examples of my face. So I'm going to do something like this, give the computer some examples of my face. Then I'm going to give the computer some examples of my left hand. And then, yeah, that should be enough. And then I'll give the computer some examples of a book. Happens to be a book that I like. And then I'm going to go to this middle section to sort of train a model. And right now it's taking a while because all of this is happening in my browser. So the tool is very, very private. All of the data is staying in my browser through a library called TensorFlow.js. So one of the main points here was to showcase that you can create these models in a really private way. And so now the model's trained, it's pretty fast. And now I can try it out. I can see that, it can detect my face. Let's see, it can detect a book. And it can detect my hand. And some interesting stuff happens. When I'm half in, half out, you see that the model's trying to figure out, okay, is it my face? Is it my left hand? So you can sort of learn things about these models, like the fact that they're probabilistic. So far, maybe not so special. I think what really unlocked the tool for a lot of people is that you can export your model. So I can upload this to the web, and then if you know how to code, you can sort of take this code and then essentially take the model outside of our tool and put it anywhere you want, and then you can build whatever you want with it, a game, another app, whatever you want. So let me go back to my slides here. We also have sort of other conversions, right? So you can create a model and not just have it on the web. You can put it on mobile. You can put it, in Unity, in processing, in other formats, and other types of platforms. And just a little note here. Of course, this is not just myself. I worked on this project with a lot of colleagues, a lot of very talented colleagues of mine. Some of them are here. And I'm going to showcase a lot of work from other people in this talk. So as much as possible, I'm going to give credit to them. And then at the end, I'll share a little document with all the links in case you don't capture them. So, okay, I want to emphasize that a lot of our projects have really humble origins. It's just one person prototyping or sort of hacking away at an idea, even though it might seem like we're a really big company or a really big team. And just to show you how that's true, the origin of this project was actually a really small experiment that looked like this. The interface sort of looks the same, but it was really simplified. Like you had this sort of 3-panel view and you couldn't really add too much data. It was really, really simple projects. But more so than that, even though it was technically very sophisticated, I think our ideas at the time were very, we were kind of exploring really fun use cases. And just to show you how much that's true, I'll show you a project that one of the originators of this idea, Chen, tried out with his kid. So let's see. So you can see he's basically creating these paper mache, figurines with his kid, and so he's training a model that then triggers a bunch of sounds. So it's really kind of fun at the time, just trying a lot of different things out. And then we started hearing from a lot of teachers all over the world who are using this as a tool to talk about machine learning in the classroom or talk about sort of the basics of data to kids. And then we finally heard even from some folks in policy. So Hal Abelson is a CS professor at MIT, and he was using the tool to conduct sort of hands-on workshops with policymakers. So we had a hunch that maybe this silly experiment could become something more, but really didn't know how to transform this into an actual tool. And we also didn't know necessarily what the best use cases would be. This is where the project took a really, really interesting turn, because essentially we met the perfect collaborator to help us and to push us into making it a tool. And that person, his name is Steve Sailing. He was introduced to us by another team at Google who had been working with him. And Steve is this amazing person. He used to be a landscape architect, and he got ALS, which is Lou Gehrig's disease. And he sort of set out to completely reimagine how people with his condition get care. And he created this space that everything is API-ified. So he's able to order the elevator with his computer or turn on the TV with his computer. It's really amazing. And so he actually found the original Teachable machine, and someone else sort of was using it with him. And, we basically got introduced to him, and the question was, well, can we figure out if this could be useful to him and in what way? And, how do we just get to know Steve and what he might want? So a little pause here to say that, folks like Steve, they're not able to move, or, in Steve's case, he's not able to communicate. So he uses something called a gaze tracker, or like a head mouse. And he essentially sort of looks at a point on the screen and then can sort of press click and type a word or a letter. So he's able to communicate, but it's really, really slow. And so the thought was, okay, can we use a tool like Teachable Machine to train a computer to detect some facial expressions and then trigger something? And this, of course, is not new. The thing that was sort of new was not for me to train a model for him, but for him to be able to load the tool on his computer and train it himself, like sort of put that control on Steve. And specifically, we basically went down to Boston and worked with him quite a lot. He became sort of the first big user of the tool, and we made a lot of decisions by working with Steve and sort of like following his advice. And one of the things that the tool sort of allowed us to explore was this idea of immediacy. So what were some cases where Steve wanted sort of a really quick reaction, and how could the tool help for this? And one use case was he really wanted to watch a basketball game, and he really wanted to be able to cheer or to boo depending on what was happening in the game. And that was something that he was not able to do with his usual tools, because he had to be like really fast in cheering or booing when something happened. And so he trained a simple model that basically he could sort of open his mouth and trigger an air horn. So that was one example. So, we kind of immersed ourselves in Steve worlds, and by getting to know him, we got to know that, maybe other ALS users could find something like this useful. So we started exploring audio. Like, could we have another input modality to be audio to potentially help with people who sort of had limited speech? And that led us to incorporate audio into the tool. So I actually have a little example here that I also want to show, just so you guys see how this works. I'm loading a project that I had created beforehand from Google Drive. So let's see if it does. This is some data that I had collected beforehand, some audio data. So there's three classes. There's background noise, there's a whistle, and there's a snap. And let's see if it works. So you can see the whistle works. You can see the snap works. So, same thing here. I can kind of export the model to other places. But the interesting thing here is that the audio model itself actually came from this engineer named Chen, and he created that audio model for people like Mark Abraham, who also have ALS, through exploring with him the same idea, like how can I create models for people like that so that they can trigger things on the computer. So the technology itself, also came from this exploration of working with users who have ALS. And you can't see what's happening here, but essentially Dr. Abraham has sort of emitted a puff of air, and with that puff of air, he's been able to turn on the light. So, we decided that, okay, this could be useful to other people who have ALS, and we decided to essentially open up a beta program for other people to tell us if they had other similar uses. And trying to think about maybe other analogous communities that could find some interest in Teachable Machine. And that's how we met the amazing Matt Santamaria and his mom, Kathy. And Matt had come to us and told us that he was playing with the tool and he wanted to try to use it for his mom. So he actually created a little photo album that would sort of change photos for his mom, and he could sort of load them remotely. But his mom, because she didn't have really too many motor skills because she had a stroke, she wasn't able to control the photo album. So we actually worked with Matt, and you can't see it here because it's just an image, but we actually worked with Matt to create a little prototype of his mom being able to say previous or next, and then training an audio model that then was able to sort of like change the picture that was being shown on the slideshow. And that was just sort of like a one-day hack exploration that we did with Matt. And then ultimately, he sort of kept exploring potential uses of Teachable Machine with his mom. And he created this tool called Bring Your Own Teachable Machine, which he open sourced and has shared online. And what it allows you to do is to put any type of audio model and then link that to basically a trigger that sends text, and that sends a text to any phone number. So pretty cool to see what he did here. And then finally, just seeing that the tool sort of ended up being useful in a lot of analogous communities. Once we launched it publicly, we saw a lot of uses outside of accessibility. So I wanted to show you a few of my favorite ones today. This is a project by researcher Blakely Payne. She used to study at MIT Media Lab, and she was really interested in exploring how to teach AI ethics to kids. So she open sourced this curriculum. You can find it online. And it just has a bunch of exercises, really interesting exercises that she takes kids through. So this one, for example, explains to them the different parts of a machine learning pipeline. So in this case, collecting data, training your model, and then running the model. She sort of gives them different data sets. So you can see here in the picture, it's a little blurry, but you can see the kids got 42 samples of cats and then 7 samples of dogs. And so the idea is for them to train a model and then see, okay, maybe the model's working really well in some cases, maybe it's working really poorly in some cases. Why is that? And have a conversation with them about AI ethics and bias and sort of how training a model is related to the type of data that you have. Here's another example of her workshop. She sort of asks kids to sort of label their confidence scores, and you'd be surprised, we were invited to join one of the workshops, and these kids sort of established a pretty good kind of insight into the connection between how the model performs and the type of data that it was given. It's not just Blakely. There's other organizations that have created lesson plans. This one is called readyai.org. And, again, they kind of use these simple training samples. In a lot of schools, you can't use your webcam. So a lot of them sort of have to upload picture files or photo files in order to use the tool. And that was a use case that we found out through education, that we had to sort of enable, not having a webcam. And then more so in the realm of hardware, there's a project called Teachable Sorter, created by these amazing designer technologists, Gautam Bose and Lucas Ochoa. And what it is it's very sort of powerful sorter. So it uses this, this accelerated hardware board is kind of like a Raspberry Pi. And they essentially train a model in the browser, and then they export it to this hardware. And they both were super, super helpful in sort of creating that conversion between web and, and this little hardware device. Now, this is a very complex project. So they made a simple version that's open source and you can find the instructions online. And it's a tiny sorter. It's a sorter that you can put on your webcam. And so again, you can train a model with Teachable Machine in the browser and then export it to this little Arduino and then sort of attach this to your webcam and sort things. In a different vein, there's this project called Pomodoro Work and Stretch Chrome extension. And what it is it's a Chrome extension that reminds you to stretch. And the way it works is that this person trained a pose model that basically detects when people are stretching, right? There's a team in Japan that integrated Teachable Machine with Scratch. So Scratch is a tool for kids to learn how to code. It's a tool in a language and environment for children to learn how to code. And unfortunately, a lot of the tutorials are in Japanese, but the app itself sort of works for everybody. So you can take any model and run it there. And then a lot of other just really creative projects, like this one is called Move the Dude. Make this probably a little bigger. So it's a Unity game that you control with your hand, and your hand essentially is what's moving the little character around. So again, because these models work on the web, you can kind of make a Unity WebGL game and export it. And then just one last example, a lot of designers and tinkerers started using the tool to just play around with funky designs. So Lou Verdun created these little sort of explorations. In this one, he's doing different poses and matching those poses to a Keith Haring painting. And then in this one, it's sort of like a cookie store. And then you can draw a cookie and get the closest looking cookie. And then this GitHub user, Sashi Do, created a really awesome list of a ton of very inspiring Teachable Machine projects in case you want to see more of them. So just to sort of go back to the process of how we made this tool, we took a bit of time to think about this way of working and informally started calling it Start With One amongst ourselves, amongst my colleagues. And it's not a new idea. This is inclusive design. I'm not inventing anything new. Just the word Start With One sort of was a way to remind ourselves that, of the tactical nature of it. Like you can just choose one community, one person, and sort of start there. And we're really just trying to celebrate this way of working, this ethos. Start With One was just an easy way to remember that. So just coming back to this chart for a second, this idea of like a tool that we created for one person ended up being useful for a lot more people. But I want to clarify that the goal is not necessarily to get to the right of this chart. A lot of the projects that we make, they just end up being useful for one person or for one community. And that's totally okay. And it's not necessarily the traditional way of working at Google, but it's okay for my team. This idea of sort of starting with maybe the impact or the collaboration first, rather than the scale, it doesn't mean it's the only way of working. It doesn't mean it's the best way of working. It's just a way of working that has worked really well for my very small team. So there are a lot of other projects that sort of fit into this bill. And if you're curious about them, you can see some of them in this page, g.co Start With One. It's also a page where you can submit projects, right? So if any of you have a project that fits into this ethos, you're welcome to submit it there. And right now that times are really hard for people. I think it's easy to be crippled by what's going on in the world. I've certainly felt that way, maybe even a little powerless at times. And for me, when I think of Start With One, I remember that, even small ideas can have a big impact if you apply it in the right places. And I don't just mean pragmatic, right? Like human need is also about joy and curiosity and entertainment and comedy and love. So it's not just a practical view of this. So just a little reminder for all of you, I suppose, to look around you, to collaborate with people who are different than you, or even people who you know really well, your neighbors, your family. I think the idea is to offer your craft and collaborate with a one and solve something for them. You know, even if you're starting small, you'd be really surprised by how far you can get. That's it. There's this link, tiny URL, Teachable Machine Community. I'll paste in the Discord, and you can find all the other links in my talk through that link in case you didn't have time to copy it down. Thank you very much.
Thank you so much, Irene.
Yeah, I'll keep this up for a little bit just in case.
Yeah, no, that's great. Thank you so much. It's beautiful to see all these different ways in which a diverse public has found ways to use Teachable Machine in ways that are very personal and often, you know, single scale, kind of scaled to what a single person is curious about, like a, you know, father and a child, or you know, people with different abilities who can use this in different ways to make easements for themselves. It's really amazing. I got a couple questions coming from the chat. So you mentioned this start with one point of view. Is this a philosophy that's just your sub team within Google Creative Lab, or does Google Creative Lab have a manifesto or set of principles that guide its work in general? And if so, what sort of guides the work there, and how do you fit into that?
Yeah, great question. No, I wouldn't say it's like a general manifesto or even of the lab itself. I would say it's a way of thinking within like my sub team of the lab. And again, like I do want to say, like it's not like I'm talking about anything new. Like inclusive design and co-design, been talking about this for ages. It's really just like a short word keyword for us to refer to these types of projects. But I would say like the Creative Lab does pride itself in basically embarking on close collaborations. So we tend to see that projects where we collaborate very closely, like not making for people, but making with people, end up being better. So not all projects can be done in that way necessarily, but I would say like a good amount are. Yep.
And so I know that there's a sort of coronavirus themed project by that uses the Teachable Machine by, I think it's Isaac Blankenship, which is the anti-face touching machine, where where he makes a machine that whenever he touches his face, it says no in a computer synthesized voice. It's super homemade, and it sort of like trains him to stop touching his face. But I'm curious, how has the pandemic changed or impacted the work that your team is doing, or that people are working with the Teachable Machine are doing, or that the Creative Lab is doing? How have things shifted in light of this big shift around the world?
Yeah, I mean, that's a good question. I don't know if I have an extremely unique answer to that, except to say that we've been impacted like anybody else. I mean, luckily, I am in an industry where I can work from home, so I feel incredibly lucky and privileged to be able to be at home, safe, and not be a frontline worker. It's changed the fact that certainly collaborations are harder to do. Like you saw in the pictures with Steve, like we like to go to where people are and like sit next to someone and actually talk to them and not be on our computers. And that has certainly gotten harder. But we're trying to make do with things like Zoom and just like everybody else.
Yeah.
I'd say the hardest thing is not collaborating with people in person, and it just takes like a shift because there's so much Zoom fatigue, and you don't get to know people outside of your colleagues. Like when I'm trying to know a collaborator or someone outside of Google, like anybody else, you benefit from going to dinner or grabbing a coffee or just like being a normal person with them, having a laugh, and that doesn't really exist anymore. Like Steve, actually the person that I was talking about who has ALS, he's so funny. Like he says so many jokes. He's so restricted with the words that he can say because it takes him a long time to type every sentence. It takes 2 minutes to type a sentence, but he is so funny. Like he has such a great personality and humor. And I think that would be very hard to come off through Zoom, starting with the fact that it's very hard for him to use Zoom because someone else has to sort of trigger it for him. So certainly that type of collaboration would have been very hard to do this year.
Thank you so much for sharing your work and this amazing creative tool. I like to think that there are several different gifts that each of our speakers are giving to the audience, and one of them is the kind of just the gift of permission to be a hybrid, right? Like, you know, you are a designer and a software developer and, you know, an artist and a creator and an anthropologist and all these other kinds of, you know, things that bridge the technical and the cultural and the personal and the design oriented and all this together. Another gift is just the gift of the tool that you're able to provide to all of us, you know, me, my students, and, you know, kids everywhere and other adults. Thank you so much.
Yeah, I mean, final words is that it's a feedback loop, right? Like I was inspired by your work, Golan. Like you give a lot of people in this community permission to be hybrids, and I didn't know that that was possible. And then everyone making things with Teachable Machine inspires us to do other things or to take the project in another direction. So I think we have the privilege and the honor of working in an era where the internet just allows you to have this two-way communication. And I think it makes so many things better. So thank you, Golan, and thank everyone for organizing the conference. Like Leah, Madeline, Clara, Bill, Linda, you guys all make hybrids around the world possible.
Thanks a lot, Irene. In a few minutes at 6:30, we're going to begin a lecture presentation by Andrew Quitmeyer from the Digital Naturalism Laboratories in Panama. And so we'll be seeing Andrew pretty soon. Thanks, everyone. See you soon. Welcome back, everyone. Hi, I'm Golan Levin, Director of the Studio for Creative Inquiry at Carnegie Mellon and Director of the Art and Code Festival. This is Art and Code Homemade, and we are thrilled to introduce our third speaker and final speaker for this evening, Dr. Andrew Quitmeyer, who studies interactions between wild animals and computational devices. He directs the Digital Naturalism Laboratories in Panama, also known as the Institute for Interactive Jungle Crafts, where he blends biological fieldwork and technological crafting with a community of local and international scientists, artists, and engineers. Andy Quitmeyer.
Awesome. Thanks so much for having me. I'm really excited about getting to talk in this whole thing. And so yeah, like I said, I want to talk today about biocrafting computers. We'll explain more whatever that means in a second. But hi, I'm Andy. That's me. I look at how we can use art and technology for interacting with nature and trying to do this in the wild. And I run a little laboratory with my partner, Kitty, here in Gamboa, Panama, called Digital Naturalism Laboratories, or our alias of the Institute for Jungle Crafts. And I'm really excited for this whole event because I wanted to try a different talk than kind of my normal talk here, and this seems like a fun venue to do it. And instead of just showing lots of different projects and things that we're doing, fun jungle robots, I'll still show jungle robots, so don't worry, you won't miss out. But I wanted to get a little bit more into the philosophy of what is going on here and why we're doing some of this stuff. And for us, this all really kind of boils down to basically the interactions between three special things in our world. This is creatures, contexts, and tools. And so creatures, you know about these creatures. They're these delightful little bundles of protein. They capture energy from the environment. They convert it into heat and more of themselves. And that's pretty much a kind of a definition of life, of living things. But one of the coolest things about these living creatures is that they come in an incredibly huge variety. And they all have different superpowers and senses and abilities, and we're still learning about this. And the reason there's so many different types of cool creatures in our world is because of the variety of the environments that they evolved in. The environments around the creatures all pose different opportunities and challenges. And the creatures change and replicate and fill niches in these contexts in order for them to survive and just continue. That's the reason why, you know, in wet places, things are good at swimming and have gills, breathe underwater, right? That's how fish work. And that's the reason why in like scary places, things are good at hiding. They have camouflage. The key concept here is that contexts sculpt whatever is inside them. And in order to deal with these different contexts, living things have to develop tools. And for our purposes, your tools are simply anything a living creature uses to interact with its environment. Maybe it's this bat's little tongue for getting the nectar out of that flower. It's the tools of this fish are its gills and its flippers for negotiating the context of its watery environment, or the tool of the camouflage that these katydids have developed all over. It's the reason why agoutis have this kind of behavioral tool of using leaves in order to hide their meals for later. A coconut can use, or an octopus can use a coconut to pretend to be a coconut. A crow can use a piece of garbage to have fun. You can have tools that are for having fun. A sloth's unique hands help it sleep in trees. These are all amazing different tools. And this is perhaps a broader definition of tools than you might be used to. You might be like, oh, those are senses, those are body parts, those are instruments, or those are interfaces. And in biology, some people refer to the tools that animals have as their proxies for engaging with the context, or the extended phenotype. But we're going to make no such distinction on the function or provenance of these things that let us reach out from ourselves. For our purposes, all tools are simply extensions of ourselves, and every way in which life can engage with the world outside of it is just another interface, another tool. There's my image. This is how people look, right, when they use tools. So this is all great. You have these fun little critters running around in neat places, doing stuff with the tools that they have. But there's a subset of these creatures that are a little bit problematic. And that's humans. You're probably pretty familiar with these. You spend most of your time being one, I think. Humans are creatures too, and they capture energy and replicate and spend a lot of their time trying to find out what makes them special compared to all the other living things in the world. Yeah, I'm a human. How am I? I'm obviously so much more special, but how exactly? And it turns out whenever humans make a metric that tries to prove their superiority, oh, we have language, or we do agriculture, we do tool making, we usually end up just finding other living creatures actually really already do this also, like honeybees, waggle dancing, leafcutter ants doing agriculture, chimps using sticks as tools. So what does make humans actually special? Well, one, we're probably the creature that spends the most time thinking about how special we are. And the second is our ability to utterly obliterate all other life around us. And this is kind of, you know, like the shortcut, the cheap way out of becoming special. You just kill everything else. And this penchant for obliteration and exclusion that humans have, it ends up even creating two different categories in this concept of what a context is. And this is different places where things could happen. We now have human spaces and wild spaces. Human spaces means basically other creatures aren't allowed in. No, agoutis, you stay out. This is human zone. Or if we do allow other creatures in, other life forms, it's only the ones that we can really designate and control ourselves. And then by defining human spaces like that, it even then forces us to invent this concept of nature. And this is all based on this idea of exclusion and control. Human spaces are where we make all the decisions. And wild places, or sometimes natural places, are those where we never had control or we've given up control in some kind of frame of reference. And of course, no space is perfectly one or the other category. There's a spectrum of exclusivity, and you know, the type of exclusivity depends on your different human cultural backgrounds and stuff. And you know, some people might have a super clean house, it still gets infested with ants. But it's this spectrum of exclusivity that humans do, which is kind of weird. And now we have this brand new tool, computers. They can run billions of commands that we tell them to do. And it's the first time in human history we actually have a medium we can tell do stuff, and it does stuff. But that's super dangerous, right? Because the things that we do as humans already tend to be horrible, right? There's my little Roomba just going around exterminating life. And this kind of brings the main problem of our little story about creatures, contexts, and tools. You have humans, and they're very powerful and self-centered. And they use their tools to modify their environments and exclude and obliterate other life forms. And I want to help people figure out ways to give up some of this control. And my hope is that there's something in this new programmable medium that we can use to somehow build connections with all the other life forms around us, rather than reinforcing separations. And so my initial thought was, okay, if I want to know about other types of life forms, I should go hang out with field biologists. And what are field biologists? Well, they're a type of human, so I'll already be a little skeptical, but they're really interested in what other life forms are doing. And they have different tools that they try to use and extend their body with. And because they're field biologists, they try to do their experiments in places where these creatures actually live. And doing their research in wild areas, it keeps the creatures in their own environments. And the goal of this is it reduces unknown variables that might come up if we had instead taken this animal out of its environment, separated it from that environment, and used it in a human space, like a laboratory. And The other side of this field biology is by working in the field, it also immerses the scientists in these very foreign, not that human of spaces. And it lets their senses and tools be sculpted and honed to all the details of that surrounding context. We're trying to actually let ourselves be changed to help understand these animal types of environments. But that also means these field biologists are confronted with a huge task of how do you make sense of anything if you're actually going to be trying to study everything, the context and every possible thing and the infinite number of variables around you that you have to deal with. And one of their main responses, these field biologists, is to get crafty. So field biologists usually confronted with, from human point of views, very strange tasks. For example, I want to make a bat go through a three-dimensional acoustic maze. Or I want to see their tongue movement when they pollinate flowers. So I need some sort of crystalline faux nectar flower surrogate. Or I want to hold a single tadpole egg that I can rotate and vibrate, and also the holder is optically clear. But there's usually not that many ready-made tools around just for these cases. If you go to Walmart and you ask for a tadpole holder that's optically clear, they might not have what you're looking for. And like noted frog biologist Dr. Karen Workinen says, she studies frog embryos. That's not something that there's standard tools for. So they have to get crafty. And these biologists usually have to end up then crafting their own tools. And these can be tools crafted completely from the ground up, like these very meticulous Tundra frog models made by Barrett Klein for these frog robots that they use, or by modifying industrial, commercial, or natural materials, kind of hacking them together to make new animal interaction tools. But they often have to craft their devices themselves. That's kind of the bottom line. And the reason about this crafting is, like Dr. Workinen notes, is because there's a lot of questions that in order to ask, you actually have to make stuff. So you have to make stuff in order to ask a question. And the really neat thing about that is for scientists, for these field biologists, the tools they create actually are the embodiment of a question, which I think is kind of lovely. But as we all know, if you've crafted anything, when you're making something, it doesn't always come out exactly how you originally thought. Oh, this is like, oh, things change. And those changes are also going to change your question at the same time. So in order to maintain the integrity of the question, you have to figure out ways in which you're crafting your tools effectively. And so the crafting process, this biocrafting, as we might call it, it necessarily includes doing things like rapid iterations, where you're sculpting and refining these scientific tools to the exact specifications of the creature, the environment, and the question that you're asking. And then at the same time is doing this type of work on site is very important. Dr. Workington here notes again, interviews that we had with her, if every design requires a trip to Boston and her field site down here in Panama, it's going to take forever and the tools are never going to get quite to the point where you want them. So this way of biocrafting, of rapidly building your own tools iteratively and on site, is done so in order to ask the questions for your environment. It's all done in order to maintain this research integrity. And the reason why this works is because tools are bidirectional. And what does this mean? It means that, this is kind of a weird concept, but we often think of our tools as things that we use to change the environment. I am a human, I have a hammer, I smash things, I'm in charge here, right? But like the classic idiom goes to, the person who has a hammer, everything looks like a nail. Your tools, actually, they don't just allow you to change the environment, they change you. They change us, and they change the way that we see the world, we interact with the world, they even change our whole bodies and our senses. So hammers let us squish things, yes, but they also turn us into thing squishers. This is my persona now, I'm a thing squisher. The leaf that the agouti was using to hide its food, it's also using the agouti as a tool for planting the babies of this tree that it's from. And the tools that we've created somewhere, they all take on these characteristics and assumptions from the context in which they were built. And so by crafting and customizing their tools at these field sites, instead of at studios far away or laboratories far away, biologists are actually working to help their tools become better suited to the context and the research problems and their own original curiosities that came up in these field sites. But now there's a whole new type of tool that scientists can incorporate. And perhaps it's not a tool, but it's a creature, right? Computers are a little funny. Just like a living creature, computers can sense things. They can create stimuli. They can react to their environments. And we call, when you have senses and reactions to things, those are called behaviors. And whether these behaviors come from natural systems or digital systems, by putting together these senses and reactions of this new digital medium that we have, it can help us understand the designs of both the creatures and the computers. And just like any other tool though, these computers are not developed in a vacuum and they're not being used in a vacuum. They take on characteristics and assumptions from wherever they were created. And unfortunately, these powerful new digital tools we have, they're largely developed in climate-controlled, human-oriented environments. And the tools that we develop, that means that they're mainly getting feedback during these iterations from the environments around them. And we have to kind of imagine like, oh, will this work in the field? I don't know, but we build in all these assumptions about what we remember about the field, and we're not actually iteratively testing them as much. What's more is if computers then present incredible new abilities. Wow, I can track every single ant in the laboratory and they work amazing in the lab, but they're not as robust to take on the challenges in the actual world, like, oh, it doesn't work because trees are round. This suddenly means in general that it ends up being the scientists and their organisms are the ones who are forced out of the original environments and have to go into the computer-friendly human spaces. This is them moving over. Oh, goodbye, field. And this isn't where the field biologists want to be, and it's not really that great for their science. And soon, and we see this in many other disciplines wherever computers are introduced, computers can bulldoze the original goals of research and instead reframe everything in a way that better serves computers. You've all seen this, like, oh, well, we need to do this because the computer wants it this way. And my kind of thoughts here are just, maybe it's the computers and the way that we craft computational tools that actually needs to change, instead of the people, instead of the environments, instead of the living creatures. And so part of this is a kind of proposal to, let's develop wilderness tools in the wild. Let's build computer stuff in the wild. And of course, that's the whole reason field stations exist in the first place, to have a human space right next to a natural place and let the scientists kind of shrink this gap between lab and field and kind of speed up these iterations that they can do. And I thought we should have the same thing for working with digital technology and nature for using computers, get them into the nature. And so I made some initial digital biocrafting stations, we called them, when I was a PhD student, which was mostly me just squatting in parts of the Smithsonian's field station here in Panama and setting up my own little soldering stations and stuff and hiding them when we had to. And we kept developing this, and we would run workshops about things, doing kind of basic interactions between creatures and computers, like wearable interactive firefly outfits, or sending messages through Morse code, sending Morse code messages through leafcutter ants with Arduinos. And this even grew into a full-time facility where I'm at right now. We have a house in Gamboa right next to the Smithsonian and the rainforest, and we converted it into kind of an art science makerspace with construction shops, 3D printers, laser cutters, prototyping workshops, electronics labs. We have a little art science gallery. That's where I'm in right now, documentation equipment, and we help run field courses, do field site maintenance for the scientists here. This even includes trying to repair these ancient bridges that are here for the scientists to get to their field sites in kind of harsh conditions. And even doing fun projects like, you know, making wearable ant farms and building interactive enrichment toys for local animal rescues nearby. We offer long and short-term residencies when there's not giant global pandemics everywhere. More about that at dynalab.net. And the most important part, though, is this lab is right next to the jungle and the forest and a place where there's these amazing, wonderful creatures. But what if we want to get even closer? And so that's where we start getting into like, I'm getting hungry. I need to get in these natural environments more and more. And so I was thinking of how do we push this idea of crafting in the context even further? And I was trying to think of how we could shrink this lab and bring it closer to the field. So we have things like mobile studios, where we literally just try to, you know, put the lab into a box and drag it out with us, like a big trailer. So for example, we're working on these portable rough and tumble jungle trailers with the local sustainable architecture company Chrysalis here. And for the idea is we could loan them out to scientists and they could stay in the forest at their field sites as long as possible. And they even float. And we've even made other floating mobile lab spaces, such as the Boat Lab, the community-made modular floating hackerspace for community science projects. We used to kind of draw attention to an endangered coral reef in the Philippines. We also, when I had some students, brought them on sailboats that we converted into floating maker spaces to build different types of scientific tools. But there's still some places that ships and vehicles cannot go. And so we can try to shrink this lab even more and push this into the idea of carryable studios. And so these are ideas help really push forward by things like Hannah Perner Wilson has made these amazing mobile studios that unpack and can store all of your electronics and devices all together. That you can then carry on things like we call hiking hacks, where we would take a group of people, we would carry all the tools that would normally be in our lab, go to a scientist field site, and we'd live and work out there, designing and reflecting upon and documenting upon as many different projects as we could while trying to stay as immersed as possible in this field site. And while we're trying to make different types of probes and tools for experiencing the nature around us. But then, what if you don't want to carry it? What if we push this idea even further and it's just part of you? This is this idea of wearable studios. Again, really pioneered by Hannah Perner Wilson's incredible designs. We realized you can never really rely on anything in this world except that, like, wherever you are, you're at least going to be there. So if you turn your body into your studio and your body into electronics work surfaces that can be directly incorporated and rapidly prototyped upon, having different work surfaces solder on your knee, keep your information and tattoos on your body, you'll have quicker access and be able to go places you wouldn't be able to with a trailer, even a large bulky backpack. And for me, this is kind of the ultimate goal here, where all of this leads. A future where one's body, laboratory, and field site are all one and the same. We can be walking, pondering, curious naturalist cyborgs with our different hyphae reaching into every nook and cranny around us and connecting us to the things around us. And so with that, that's most of what I wanted to talk with you about. Yeah, we can answer questions and stuff. I have lots more random other examples and stuff I can show, but yeah, I would love to just get feedback, questions.
Andy, thank you so much. This is incredible. I have a bunch of questions stacked up from both the chat and also from my own thing here. But first, I actually wanted to bring the attention of the audience to something that you contributed to, and also many of the other speakers as well, which is the Art and Code zine, which is downloadable from the Art and Code Homemade website. And in particular, you contributed this thing called the touch tire, which is a plan for a kind of capacitive sensing tire. Apparently, you use the metal mesh that's inside of the rubber tire to sense the presence of an agouti, and then as a result of an Arduino sensing this this agouti, I guess the agouti gets a shower or something like this. Can you tell us about tell us a little bit about this particular contribution and how it arose?
Yeah, definitely. So when you're working with a lot of wild animals, like at the animal rescue, we have an agouti, and we also have this 400-pound tapir. And so usually electronics, like I was mentioning, they're not usually that durable. They're kind of wimpy. They don't want to be out in a rainstorm. They don't want to, get chomped up by a tapir. And so it can be hard to think when we're doing interaction design. A lot of the normal interactions we come up with, they're like, oh, this button we're going to press that has a different, letter on it or something like that. Doesn't really work for a tapir or an agouti. And it also, it needs to be rained on and all this kind of stuff. And so I was trying to think of what's the simplest interface we can use that people would have access to that would be really rough and tumble and durable enough to withstand a lot of abuse, but still allow for lots of different kinds of interactions. And I had this realization that, there's old tires all over the place. People have access to them. And I realized that tires, I guess, they often have like a metal mesh inside. And so you drill into it and you can just put a chain through it, something real, also indestructible, but metal. You can then send this chain, put it around a tree, send it over somewhere, connect an Arduino to it safely away from the tapir, and maybe a climate controlled space or something like that. And then you have this thing that you can really beat up and chomp on or get rained on, and you can still get some data about who's interacting with it in different ways. And from that, like at our animal rescue, we have some showers that the tapir really likes playing around in the shower, or hides their leaves in different places, different animal enrichment to keep their brains going. We can trigger all those different kinds of things like that. And so this is a kind of thing that I'm working on right now throughout this upcoming spring. I hope to actually get some of those going. So I'll be posting updates whenever possible.
Got a couple more questions. So one question is these workshops that you direct. I realize we're in a pandemic, but can you talk more about the residencies and workshops that you direct and sort of who comes to them and, is something that people apply for and tell us how these happen and how long they last and what people do.
Totally.
Is this where field biologists develop their crafting skills? I mean, like tell us about that.
That's one of our goals. So we work, of course, with a couple different audiences. So we were actually scheduled to host a bunch of people who maybe more identify as scientists. They're field biologists. They're part of a taxonomic organization. And we were going to host them last June to do a workshop on building different sensors. But other times we'll do workshops with maybe artists and show them different scientific techniques and stuff that people are currently doing in the field. But usually what we try to do is always just get a nice mix of people. So at our house right here, our residency, our lab, our Institute for Jungle Crafts, we have 2 bedrooms that we normally would host residents in, but since the pandemic, it's been kind of locked off. But we had people here who were, for instance, a scientist studying bats, people studying soil microbes, and we had someone who does designs for the reinas in Carnival. So like fashion design kind of stuff, but is also a very avid birder and bird scientist. So we try to mix that up a lot. But then, and so we do smaller workshops and residencies. We had a whole schedule lined up for both local residents, artists and scientists from around here in Panama, as well as international residents and scientists. We even had some scholarship money to help them come that we're just funding from our own freelance work that we're doing here. But we had to cancel that all last year. And unfortunately, Panama's been under really strict lockdown, which is good that people are taking it seriously. It's very unfortunate that the government here is not doing things in smart ways. And so they're launching kind of discriminatory practices against trans people and having this gender-based lockdown that basically effectively imprisons people who are non-gender conforming. So that's really sad. But so everything's stopped here, but hopefully it'll start going again and we can help host people. And then our biggest thing that we run is this thing called the Digital Naturalism Conference. And that's where we'll get like 100 people try to rent out a place for some semi-remote location. We did one in Thailand, we did one here for an extended period of time with the goal of just letting people interact with nature. And people had all kinds of different backgrounds from that. People were comics book creators, basically everything. The only key thing was you were interested in interacting with nature in some way. So if you go to dynacon.org, you can actually sign up for our mailing list and we'll send out info in our little mailing list whenever we have the residencies and the conference going again. Hopefully it'll be soon and people all are safer around the world.
Thank you so much, Andy Quitmeyer. It's been an immense pleasure learning about your work at the Institute for Interactive Jungle Crafts and Digital Naturalism Laboratories. Thank you so much. And for everyone else, this concludes our transmission for Thursday evening. We begin tomorrow morning at 10 a.m. Eastern Time, United States Eastern Time, with Max Bitker, with the Friday morning session of Art and Code Homemade. Thank you, everyone, and good evening.